next talk. Dr. Lam, would you like to introduce your student?
Yes. So this is Mr. Yunis Korku. He's a CIS, Computer Information Systems major. Yunis took a course called Predictive Analysis from our data science program last semester, and this presentation came out of that course.
Hello everyone, again my name is Yunis Korku. My project is predicting Airbnb listing prices in Seattle and multiple regression analysis. So the project's goal was to develop a model to predict the Seattle Airbnb listing prices using multiple regression analysis. Multiple regression is a statistic technique used to analyze the relationship between a dependent variable and two or more independent variables. So here's a formula and calculation of multiple linear regression that we use. So it goes like this, where yi is the response variable for the indexed observation, theta 0 is the intercept term of the model, theta 1, theta 2, and so on. These are the coefficients of the model which represent the effect of each predictor x on the response variable y. And xi1, xi2, and so on. These are the predictor variables or independent variables for the indexed observation. And ei is the error term for the indexed observation, representing the difference between the observed and predicted values of the response variable. So our data set, I got the data source from the Kaggle, featuring 92 columns and 3,819 listings. So we will go through, I will just show you a quick view of our data set. It's a long one, really long one. Yeah. There's a lot of information. Yeah, looks like this. So the first step was data cleansing. We had to remove some data, remove some irrelevant variables like IDs and descriptions. We reduced the features from 92 to 38. 32 of them were numericals and 6 of them were categorical. Weekly price variable, it was 33% of the variable was missing, so we had to deal with that, and we estimated the missing values using daily price times 7 minus average daily minus weekly price difference. Bedrooms, there were only 6 missing entries, so I just dropped the rows. The transit, I used binary for one was for nearby transit and 0 was the transit was absent based on the description. There were amenities, there were 23 binary dummy variables used, 1 if it was offered and 0 if it was not offered. For unique amenity types in common separated list. There was another variable called weekly price. It's just the 7 times the daily price, so I skipped it. For numerical variables, they were normalized for scale comparability, enabling direct coefficient effect magnitude for assessment. So the other step was we had to look through our correlations between the numerical variables. I set the benchmark for 0.3, and then any weak predictors that were below the benchmark, I excluded them. The following variables were the ones that met the benchmark point: bathrooms, bedrooms, occupancy, beds, weekly price, monthly price, secure deposit, and maximum guess. I conducted ANOVA to assess significant differences between categorical variables and list price. Transit was excluded due to higher p-value. Neighborhood, property type, room type significantly affect listing prices were the ones that we kept. So I will just go to R and run the code here. So as you guys can see here are the p-values way below 0.05. So these are the statistically significant values. For neighborhood class, property type, and room type, they all are really small. But for transit, it was 0.219, so we had to exclude that. The variables in the model, the dependent variable was the listing price, of course, and the independent variables we kept for the model was bathrooms, bedrooms, occupancy, maximum guest, neighborhood, amenities, room type, and property type. The second step was splitting the data. The data was partitioned into training 70% and testing 30% test sets. And then I will run that code as well here. here I'm going to run the first model and we will look at the summary. So these are what our variables, what our results look like. I will go over them in the PowerPoint. Our statistically significant variables were bedrooms, bathrooms, occupancy, and maximum guests. Neighborhoods that were also statistically significant were also here. Amenities and property type were also here. So if we go look at our results, let's say for bathrooms, our coefficient estimated standard is 24. So this means each addition of a bathroom had, on average, had a price increase of $24. For bedroom, it's the same. For neighborhood, if it was, let's say, if the neighborhood was Alki, compared to our base neighborhood that was chosen by the R, the price goes up by $35. And then we had another model, stepwise model here. We'll just run the code here and I will explain it to you. So stepwise model it's a method used to add and remove variables to make the model most accurate. Here we use that method, and when we look at our results, this is what we got for adjusted R-squared. Adjusted R-squared is the variance between our predicted values and how much the dependent variables explain our listing price and variance. So for proposed model it was 0.62, for stepwise model it was 0.604, which are relatively close to each other, but again our proposed model had a little bit slightly better score for that. And then here we standardize the data, and I will run the code for that as well, and I'll explain that as well. Here's our result, what results look like. And then so we standardize the data for numerical predictors to compare their impact with each other. So top numerical predictors were bedrooms with 28.19 and occupancy as a second with 16.915, bathrooms with 15.6 and maximum guests with 4.5. So if a person wanted to list his house for renting, the bedroom would affect the price the most with 28. The second would be occupancy with $16, bathroom would be $15 each, addition of a bathroom, and maximum guest would be 4.5. Thank you. Questions?
What caused you to choose Seattle?
Nothing in specific, it's
Okay.
just
You had a connection to Seattle, right?
Well, the data was from Kaggle, right?
Kaggle.
So they probably just collected it from Seattle.
Yeah, okay.
It's a Kaggle, I believe, is just a data repository of some sort. They use like competitions or stuff like that. Somebody can correct me if I'm wrong on that. Okay, yeah, so probably just that.
How do you plan to use the skills that you gained from this on a future project?
On a future project, for career-wise, I want to do data analysis, so it's going to help me, I believe, to get like this whole project helped me get a better understanding of like how data analysis actually work and what we do, the process and each step, how it affects, and then how we get results and how we interpret them. So it's going to help, I believe it's going to help me get a good job. And I will hopefully know what I'm doing in the job as well. So, yeah.
Sure. Okay.
So I kind of, can you go back one slide? I just have a quick question
Yes.
on the occupancy and the maximum guest.
Yes.
So occupancy means how much you're for spending that night? Is that
Yes.
what it is?
Occupancy is how
How many people are allowed?
yeah, how many people are
And then the maximum guest.
You can bring me some guests.
Oh, okay, all right. So, okay, I guess what was leading to my question was something I wrote earlier when you showed your model. Is there a potential interaction term with your occupancy and your maximum guest? And was the model looking at interactions or not just looking at individual variables? That was my
I
question.
think for that specific one, we did not look at.
Okay,
I checked with the data a little bit also, like during the semester, and we didn't see any, significant interaction effect actually. But one thing I would say is like if you do it based on the neighborhood, like split the data based on the neighborhood, some of the interaction effects might be significant.
yeah, okay.